I'm going to have to actually just write on my grid too. So here's what I want you to write, and hopefully we can read this through my grid. We're going to do f of x. We're only going to do 2, so you have pretty much plenty of room for all of this. Equals x plus 2. Yeah, just write it on your like in your ISN page, just on your lines. You have lines. I don't really know how to switch back and forth on this thing. Actually, I do. I can hide it and then put it up there. Oh, not with that in the way. Maybe I can hide it. Grid. Yeah, let me make it invisible and then I'll put it back. That way you can read it better. Okay, x plus 2 over x squared minus x minus 6. Okay, so the first thing we want to do is look for our discontinuity. So in order to do that, we need to factor this. Okay, so this is our original here, and then we'll go from there. So this becomes f of x equals x plus 2 over, is that pretty easy to factor? Yeah, 2 numbers multiplied to give me 6, negative 6 rather. So 2 and 3, which one's negative? The 3. Okay. So do I have any discontinuities here? Yes. Do I have point discontinuity? Yes. So I have point discontinuity, right? My point discontinuity is at, what's the x value? Negative 2. Okay, and so then that means I can cancel those out. So now I get that that's equal to 1 over x minus 3. Remember, it's going to behave like this graph, but have a hole here. And when x is negative 2, y is going to be what? Negative 1/5. Okay. So there's my point discontinuity. Do I have a horizontal asymptote? Remember, we had top heavy, bottom heavy, tied. This is bottom heavy. So does it have one? Yeah. Look at your notes from yesterday. Bottom heavy. Bottom heavy for horizontal asymptote. What is that? Y equals 0. Okay, so we do have a horizontal asymptote. It's at y equals 0. Do you have a vertical asymptote? Doc told me this stuff was a review. I knew. Yes. Okay. So remember, you've got point discontinuity. It's when you have a common one in the numerator and the denominator, right? Vertical asymptote is when you have a unique one in the denominator. That is unique to the denominator. So I do, and it is at x equals 3. And then horizontal, if it's top heavy, there isn't one. If it's bottom heavy, it's y equals 0. If they're tied, that's when you do the ratio thing, right? And then how do you know if you have a slant asymptote? What are you looking for? The quotient. That's when it's top heavy, right? So when it's top heavy and the degree is just 1 greater than the denominator, that's when you have your slant asymptote. So do I have one of those here? No. Okay, so I've got all this stuff. Now, is this a parent function you know? It's just the inverse, right? It's just basically 1 over x that's been translated, yes? So that you've known for a while and you know what it is. And so if you just think of what that is, does that have a horizontal and vertical asymptote? Yeah, it does, and it always has, right? So you know you should get, I mean, they may not be what it is at the, at the parent level because it's been translated, or transformed rather, then you know you should come up with the answers there. Does that make sense? There's a couple different ways to think about it. They're not all going to tie to a parent function directly. Today they are, but not 100% always, but that's how we're going to know, okay? So is this a parent function that you can graph? Yes? Right? I mean, or you can graph the parent function, then you can graph the transformation, right? We've done that. That's old business. We've already done it too. So these two things always kind of came along with that anyway, just graph-wise, because we know the whole thing moves, but we're looking for it algebraically as well. But now we also have a point discontinuity that we have to look at, okay? So now I want you to take underneath where you wrote all this and take the long graph that you have and put it down long ways underneath it. Just like stick it on the paper. Yeah, peel it off and stick it down underneath there. And let me see if I can get my grid back. Oh no, where's my grid? There we go. And that one. Okay, so just kind of midway through whatever you have, I'm going to probably try and use this. We're going to draw our X and Y axis. So there's rulers on your table if you want to use those. I guess I can't do that. Why isn't it drawing? Oh, because it's horizontal. You can use rulers if you want. Your ID makes a great straight edge. There's my X and Y axis. There you go. I sort of cheated. And my graph is going to kind of maybe go into my words. Yours probably wouldn't, but I want you to be able to see what I have written as well. Okay. So let's put in here what we have. We have a point discontinuity, so we have to make sure that we actually take that into account. So the point -2, -1/5 is supposed to be on this graph, but it can't be anymore because there's a hole there. So I'm going to go to -2, -1/5. You're going to have to kind of eyeball it, and that's okay. And so -1/5 right about there, but put a hole. And especially if your graph's kind of small, you want to make the hole kind of big so it's obvious. Then we graph the asymptotes. So your horizontal asymptote is at y = 0, which I think sometimes we get lazy and we either don't think of them as being asymptotes or we don't draw them in because it is an axis, but then I think sometimes we forget that even exists. And then x = 3 is my other one, so I'm going to draw that in as well. Okay. Everybody with me? So I've got my two asymptotes, my hole. Now, this is a parent function. I'm going to say at this point, I can't think of a reason that we need 1,000 points because then you are just basically wasting time trying to plot points. And so if I didn't move it over 3, then it's just 1/x. And so you can treat these like the axes. Pretend like it's the x and y axis. And if it's 1/x, when x is 1, what's y? 1, right? When x is -1, y is -1. So there's a couple key points right there. Does that make sense? Or you can actually think about what it is. If I plug in 1, right, then I get, I can plug in 4. If I plug in 4, I get 1. But you can also just think about it as actually the translations. That's why we talk about those things. So there are my key points. You should know what the shape is because it's a parent function, right? We don't have to go crazy with any of that. And I guess I'll go through my words. That's not good, of course. It's going to hug the asymptote and look something like this. Now over here, I have to make sure I take into account this hole. Right, so it's hugging the asymptote. I don't go through that hole. It goes like this. So basically, graphing your parent functions again, but paying attention to holes, because the asymptotes were things that we already looked at and should have already been familiar with. We're just looking at them from an algebraic standpoint instead of from just a graphical standpoint. Any questions about that? Are we all good? No? No questions at all. Okay, so then underneath that, we got one more I want to do. And I got to turn my grid off again. I was all prepared with my grid, but now I got to... My recorder's in the way. Okay. So now for the second one, we're going to use f of x equals x squared minus x minus 2 over x minus 2. Okay, so this is my original one. So I want you to find point discontinuity, if there is any, horizontal asymptote, if there is any, vertical asymptote, if there is any, slant asymptote, if there is any. Okay, I'll give you a second to do that. so that's what I got when I factored it. Is that what you got when you factored it? Is it going to have point discontinuity? Yes, it is. So I know I'm going to have point discontinuity. The x value would be what? 2. So then when I cancel these out, my reduced one is that this is equal to just x plus 1. So what is this going to graph as? What's that a graph of? Don't overthink it. It's a line, right? So is it going to have any of this stuff? Nope. When you look at the original, it looks top heavy, but that you have to look at the reduced one when you're looking at slant asymptotes and all that kind of stuff. So once I reduce it and I get to that, these are all none. I don't even have to do anything, right? I have to answer that it's none if I'm asked the question, but okay. So then take your little, oh wait, I got to figure out what's the y value when x is 2, 3. Okay. So now take your other little grid and place it underneath wherever you wrote that. I'm going to draw in my axes again, maybe. So when I go to graph this, and I have point discontinuity at 2, 3. So I know at 2, 3 what's happening? A hole. So at 2, 3 I'm going to make my hole. And then basically I'm just graphing this. I just have to take into account the hole. Because remember, it acts like that, but a hole at 2, 3. So to graph this is easy. I go to 1 on the y-axis, and then count my slope, up 1 over 1. Well, look, up 1 over 1, there's the point that doesn't exist. And then I can draw in my line with a straight edge would be nice. I'm going to cheat because I can. And this kind of look like this. Right? For the most part there. Alrighty. So really we're just graphing a line. It's just got a hole at 2, 3. So make sure you don't forget about your holes. For those of you that leave here and do everything on the calculator, a lot of the calculators won't even show you the holes question. Unless you do fancy things, which if you'd have just done it by hand, you'd be able to figure it out anyway. Okay? But it's important that you understand the concepts without that calculator. Any questions? We good? So the only new part from yesterday is just adding on to it the graphing aspect of it. Okay? With just the parent function parts of it. Okay? Are we good? Any questions? Okay. I think you want to keep your notes handy